So I'm trying to get caught up with everything today.
No, not easy.
No, it's not. Well, I just realized, like, 'cause I was kind of taking a little bit of a break from this, like reading some of the stuff, and I was going through it, and I was like, okay, like, like once you step away from it for a little bit, then you start reading again, you're like, whoa, there's just a
that's
lot.
funny. Yeah, it's funny you should say that, because that was a comment I was going to make, is that even after a week of not looking at this chapter and then looking at it again today, getting ready to finish it, I'm like, oh man, what? I kind of, some of these things kind of like fell out of my head. They didn't stick in there too good.
Yeah. And so I was like sitting through, I was going through it again today, and I was like, okay, kind of remind myself of everything. So this is like metaprogramming is like, this is challenging. I mean, the base concepts make sense, but then once like Hadley starts getting into like more of like the rules and exceptions,
Yeah.
like, okay, this is a lot.
Yeah, try to wrap your brain around what's going on. Some things aren't being evaluated, some things are being evaluated. What order they happen in, where is it looking this variable up in what environment? And it's really easy to lose track of that. I mean, and think about and reason about.
Yeah, and then it's like relying on like stuff that like that we covered like a long time ago. Like when I was reading through part of like evaluation, it's just like, okay, now we got to remember environments, we got to remember this, we got to remember this, and you're like, all right, now it's putting all the pieces together.
Yeah, I mean, it's one of these things where it's like for your day to day, if you're not going to use this very often, except maybe which is okay. I mean, I'm going to tell myself that it's okay to not remember all that. It's good to know how it works. If you ever did have to go back and like write some of this stuff. And the big thing it helps you with is, knowing a little bit more what's happening when you're using like the splice operator or the inject operator in your tidy eval, which as a user, that looks very useful. I never used it before, but it looks very useful. Like in the eval chapter, there's an example of, in the very end, I think, of the chapter, of like, because what's the big problem? You want to be able to avoid having to repeat yourself a lot. And now I've learned some ways to like capture some patterns that would be hard to do before, right? Like the LM example, where this is always going to be the same outcome, but I have different predictors. Rather than having to write all this out, everything else can be this. I've always just cut and paste and then like changed a little bit. But then if you change your mind about something else, you got to change in all those places, and then you forget one every single time. You always forget something. You're like, why is that number? Oh, I forgot to change. I just changed my mind about the family I was going to use or something. You know what I mean? Or if you do Bayesian, I changed my mind about the prior I was going to use. I only changed it in the first one. I didn't change all the rest of them. So being able to like capture that with a function factory, or with the with that tidy eval thing they showed in the last example there, that's something I will use. Hopefully I'll remember to use it.
Yeah, that makes sense. Yeah, some of the more practical stuff definitely was a lot more helpful. So let's see. I thought Ryan was supposed to join us because I thought he was going to cover a little bit of, I know we were going to finish quasi-quotation, but
he's going to start the eval, right?
Yeah, he was going to start the eval.
I haven't heard from him. Usually if he's going to be, he'll sometimes message me, let me know what's going on, but maybe he got caught up too.
Yeah, he could have got caught up. I'll give him a couple more minutes here, and then we can finish up quasi.
Yeah, worst case, we just finish up quasi-quotation, and you'll get a little more time to get caught up, so it'll be a win.
Yeah, no, I definitely need to like, oh, there's Ryan. I definitely need to reread like the evaluation chapter for sure, because it's challenging stuff. So, hey Ryan, we were just talking about you.
Hopefully all good things.
Not bad things.
Always, only good things.
Man, this book is I'm starting to like it. I mean, I kind of haven't enjoyed some of like the stuff, but I think this I mean, I'm still kind of lost, but the whole closures and evaluation, and I feel like this is probably the stuff that I need to learn the most, because anytime I have errors, there's always something about a closure or an evaluation.
That's a good point.
We
were just talking about that. We were just saying, like I was saying, that it was a week ago that I did the closures. I opened up this book and started want to remind myself what I had to still cover. And I'm like looking, I go, oh wow, some of this stuff's falling right out of my head. But I was saying to Colin though that some of this stuff though won't fall in my head. Some of the more practical things, like in the evaluation chapter, that great example of being able to like write a function that generates multiple fits, where you're just changing the predictors and everything else stays the same. That's so useful, because I don't know about you, but I've usually just done that by cut and pasting the big old long thing, cut and paste the big old long thing again. And then if I decide to change something else in the model, well, I got to remember all those cut and paste, or keep track of it. Usually I don't. It's a big mess, but if you make a nice little function where it captures all that, then you just change it to one place, which is, the old principle, don't repeat yourself. So I'm hoping that I'll remember to use that cool like splatting, or what do they call it, splicing thing in the evaluation, tidy eval.
Yeah.
Okay, so maybe I should get started on finishing up my section.
Yeah.
Yeah, that'd be good.
Okay, that should show you the ... section, right? That's where we left off. No, this stupid thing's in the way. You can see a black square probably.
Oh, I can see your notes.
Okay, it went away. So we last left off, we were talking about, this is kind of like the practical application of just the quasi-quotation, without getting into the full evaluation part that Ryan's going to talk about. But already there's some good practical applications here. One of the common things you might want to be able to do is, if you have a function that takes a bunch of arguments, is you might have a list of what you want those arguments to be stored in a list. How can I get those into the function, right? In BaseR, there is a way, which we'll talk about in a minute, but in tidyverse, there's this cool, we can use the same splice operator we already learned, the bang, 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 to do it, as long as it's a tidy type function that supports this particular, what's called dynamic dots, right? And most of the tidyverse, or all of the tidyverse, I guess, supports dynamic dots, so you can use that there. And he gives a couple of motivating examples. I think I did talk about that last time, all right, this motivating example thing. So the real next part of this is to talk about how we do this for our own functions. How can we want to write our own functions that have the same capability to support the dynamic dots? And for that, you use this thing called list2. So you just collect the results of the dots in a list with list2 in a list. And here's kind of an example. He presented this function called set attribute, which is going to take some object and then a set of arguments for where you want to set the attributes to, right? And it captures them all with list2. So these are going to be dynamic dots, and then just uses the attributes, just assigns the attributes straightforwardly. That part of the function is straightforward, right? Then he gives an example like, oh, well, I take a list 1 through 10, or a vector, and I want to set the attribute w to be 0. Oh, I also want to set these attributes, they're stored in a list, right? And I also want to set this one particular attribute whose name is z, but the name of the attribute is stored in a variable. This is where I can use the tidy dots. I can just use bang, bang, bang to splice in that list, x equals 1. So it's just going to expand to x equals 1, x equals 2, where this thing I've highlighted is. And this bang, bang attribute is just going to inject this letters, the z, in there for that attribute z. And if I then print that out, you can see that it worked just as advertised. And this is something we can use in our functions without any difficulty by taking advantage of simple list2 thing. That's all it takes. Just use list2 to capture them, and you got them all. And then your users can, yourself is probably the most common user, but you can use these injection things to help make it work a little easier. I just wanted to quickly highlight one of the exercises he gives here. This is that same exact function, except slightly different. He asks, what is the problem here? Why doesn't this work? When I go, okay, set attribute 1 through 10, x equals 10, it gives me this error, attributes must be named. Can anyone see the problem?
Oops.
You didn't notice me making you think so early in the morning, so early in the afternoon.
Early in the afternoon.
Early in the week.
Early in the evening, really.
Yeah.
Ugh.
All right, well, I'll just tell you, the issue is this: I changed the dot x to an x, and this is the same x as here. So when it evaluates this, it actually puts in the object in there. It actually evaluates this x to the object. So that's why all these tidy functions all have like dot x and dot f and dot data and dot. It's just to this is what data masks are for. This is one of the things I'll be talking about, I think. Yeah. So this will help. This is one of the reasons why he uses the dots for all their functions, just so it's on more or less, it's less likely that you're going to use a variable with starting with a dot. And I guess that's a good rule of thumb, by when you're doing your own stuff, don't use variables that start with dot unless you're doing something like this as a function argument to avoid clashes. All right, so another thing is, well, what if I have another function I want to use, somebody else, some already existing function is not a tidy function. Is there some way I can still use the tidy dots? And there is, or dynamic dots, there is called, use this function called exec. So exec is a function that, wait, exec is in Erlang, isn't it? Is it in Erlang? I forgot already.
I don't remember.
Let me ask the machine. Yeah, it's in Erlang. So exec is in Erlang, and what it does is allow you to call any function, but to be able to use the tidy dots for all its for some of its arguments, right? So you can do splicing like this with the arguments. You wouldn't be able to do that with me normally, but by using exec wrapping like this, you can splice in like argument name equals argument value, where argument name is NA not removed and argument value is true, right? And it works. It's also exec, incidentally, this is like a side remark in the book. It's not really part of the tidy evaluation or tidy dots. He just makes a point that another use of exec is whenever you like have to map over a list of functions, it's very convenient to have this exact thing because you can just map over them in this way. That's just an interesting example. The next thing he mentions is dots list. List 2 turns out is actually defined in terms of this other thing called dots list. And dots list, well, it says a wrapper for dots list. I'm not sure if that's 100% accurate. Actually, I think about it. What is it, Erlang? I mean, it sort of is, I guess. I mean, I looked up the definition of it. It calls FFA. It calls it through the FF4 function interface. So it calls the C code. It does call dots list though. This calls the C code directly. It doesn't go through another R function. So it is true. It's a wrapper. Never mind. And the point of the dots list is just a more general form of the list too. So you can fine tune how you use it. Normally, one of the big ones is normally list 2 will ignore trailing commas, which is convenient when you have a whole list of. And you probably know this because you know in many of the tidy functions, you can just have a list of things, arguments, and you have a trailing comma, it just ignores that. It doesn't worry about it at all. You can change it so that's not the case. So we'll actually grab those empty arguments. And if you do, you can control with preserve empty exactly what happens with those empty arguments if they're not ignored. And there's also an option for the homonyms, whether or not you want to rename them or do something else with them. The default for list 2 is just to keep them though. So that's just some technical details that probably will never remember, but they're in the book. If it ever comes up, like, oh, I wish I could deal with this empty better, or something. I don't know. Then the last subject of this section is how baseR does have a way to paste in a list of arguments. It's called do.call. So do.call will call the function, and then you give it a list of arguments as a list, and it will call them with those expanded out or spliced out in the Erlang terminology. And one exercise he has here is, how does this work? This is one way you could implement exec. You could say, okay, it's a function, it takes a bunch of dots, captures the environment, and it just does calls do.call with the list of arguments which you've captured. And that's basically, it says explain how it works. I'm not sure, it seems pretty straightforward. The key part of how it works is this list 2 thing, right? That's the key idea, is that we're going to enable the remember what exec does is it enables tidy dots for other functions. So we're going to enable that by using list 2 to capture the tidy dots or dynamic dots. I think they're calling it dynamic dots. I keep calling it both, but and then just uses the do.call with now args is just an ordinary list. It's already been expanded out, and the baseR function can handle it. Okay, so I'm going to close this section. We're out of time. Oh, freaking, I'm fast. Could almost finish this up last week. Am I going too fast? Probably. All right, so there's several examples at the end. I'm just going to call these 2 that I thought were really interesting to me anyway. The first one was map reduce example using the map and the reduce function from per. The idea was what this is going to do is take some kind of linear. You normally have like a bunch of coefficients for a linear model. I want to be able to like turn that into an expression that I can then plot and do other things. Normally, if you're like me, you just write this out in longhand. Oh, C0 plus C1 X plus, and it's fine, but it'd be nice to be able to automate that. And there's this nice example of how to do this. Returns an expression corresponding to a linear model. So it takes the variable, it takes vowels, should have been called vowels, I guess, but it takes the list of the coefficients. So the first element of this list is the intercept and the slope, and the quadratic, and so on. Or sorry, not quite. The intercept in the first variable, the second variable, and so on, right? And it's going to, so first thing is going to capture the variable as a symbol, right? And then it goes through and it's going to use map to create a bunch more symbols, basically, right? Of this form, whatever the variable is, like it's X, can be X sub 1, X sub 2, blah, 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 right? And then it's going to, now it's going to use map2 to grab each of the coefficients from the coefficient list, each of the coefficient names from the coefficient name list, and then build, and this is a map notation, but build up the terms, right? Build up each term by just injecting in the coefficient and injecting in the name of that thing for that coefficient. We leave out the intercept because that's treated specially, doesn't have a X sub 0 for X sub 0. So then we just add on the intercept to it. And then now we've got this list. We want to just do a reduce it with the sum operator. And again, we're using expression all the way through because we're creating expressions. We're not actually calculating anything, we're creating expressions. So in the end, we end up with an expression. So here's an example. The variable is X, the coefficient, or the root of the variable, I should say, is X, and the coefficients are 10, 5, minus 4, and it just spits out this nice little linear model built from that. And then you could go on and use a val to evaluate this if you wanted to, like to plot it or something like that. Another cool thing in here is this new function. Remember we learned before about function factories. You probably, like me, you've probably forgotten everything about function factories you ever learned, but no. Maybe you remember a lot of it, I don't know. The function factor is another way to do it. Instead of using a function that returns a function, you can use this thing that will create the function from the components, from expression components, from unevaluated components. And it just takes 3 arguments, essentially. It takes the arguments for the function you're creating, the expression that represents that function. And here we're using the injection to, because what this thing's going to create a power function for a given exponent. So I'm just going to inject that exponent, which is just a number. I don't have to capture it as an expression, just a number. I'm just going to inject it in here. And also the environment, which is just the caller environment in this case, right? And then we create this function. So we can create power of 5, and here it is. Power of 5 is function x to the, power of 0.5 x to the 0.5. So that's kind of neat. And he uses that again in the eval chapter. So I think it's something to keep in mind, this new function thing. And I don't know if this is more or less convenient than the function factor. I can imagine some cases where you're trying to do some complicated things where it can be much easier. This is kind of like a template approach, right? I'm like, it's like a template for what the function is going to look like. And I just put in where the template spots are, whatever the fixed components are. So I can see how that might be a little bit more easier to read. If it weren't for all these like expression things, then I guess got used to that, I guess. But this expression it's a little noisy, but this is cool that you can just have this little template part.
So we basically captured the intent. The intent was to take the power. So take the power of some value.
Yeah.
Right. And so to evaluate this, we would need to, which we'll get into, evaluation. I'm just like talking to make sure I got this in my mind.
Well, no, this function is ready to go. You don't need any more things.
Okay,
it's actually ready to go. Yeah, so here it is. That's the actual function. So if I called power, I don't have the R thing, but if I did power 0.5 and then of x, where x was like 3, it would compute the number. It doesn't need any more evaling, because that's how function, that's how new function work. New function creates the actual function, right? Mm-hmm. Whereas that previous thing actually created an expression, this actually creates a function from expression. So it's doing the eval in some sense, right?
So then if I wanted to have x, if I wanted to get, so power is now a function, right? Mm-hmm. Okay, so then how do I get x? How do I get x into that? How would I get that to, like, if I want to take,
hold on, I'll bring it up here in a second. I'm a little bit ahead. I mean, we're doing good at time, so I think I'm trying just to delve in this for just
Oh,
as
yeah.
soon as I find it.
Because I get the intent of this is like it's like a function factor where you're just like creating a function from those expressions.
I'm gonna switch screens. How do I do that? Do I have to stop and start again? Is that what we have to do? All right, so now you should see my R.
Yep.
Here's that same thing again. Remember power, right? Exactly what we had before. And I defined this function power 0.5. Okay. All right, there it is. All right, so I didn't actually assign it to anything though. I could have, for example, but we don't have to. I can just say, okay, power 0.5 of what do you want to take the square root of 2? There you go. See?
Okay.
Or I could define it.
Oh,
I could define it in thing, you know, pow 0p5 or something like that, right? And I could just use pow. I should have named it something a little bit easier to type.
5.
So
Oh, okay. Okay. I think I see which. Okay. Okay, that's such a funky syntax with like the power. Like I know it's like a like it's that's just syntax. It's just odd to me that you can see that actually evaluates to
yeah,
that answer, but it's just a function. I mean, it's
Yeah,
well,
it's
it's
just a function.
creating a function from expressions.
yeah. Once
But-
it's a function, there's really nothing special about that function anymore. It's just a function. Forgot all about the funny business we used to create it. So, like I said, that's kind of a cool example, right? I mean, it's like it kind of makes you think a little bit. The last example is this curve 2. Again, this is a built-in. It's not built-in, but this is part of the graphics package. This thing called curve that allows you just to plot an expression without having to create an intermediate function at all. Well, on your own anyway, it must do something. And one way you could have been implemented is illustrated in a book like this. I thought this was really cool. Again, it's another use of this new function thing. So you just pass in this curve 2. Well, here's the example, right? Let's look at the example first. Curve 2, I'm just going to say, okay, plot sine of exponential of 4 times x. You have to always use x, okay? Now, maybe in the real one, you can use something else, but this always has to be x. And give me 1,000 points, it just plots it, right? I never had to define the function, just put the expression in there, which is kind of cool. There's a quick, like if you quickly want to plot, like, oh, what is this logistic function? Well, okay, I see. Okay, now I remember now. That type of thing, without having to go through a lot of steps. It could have been defined this way. These are relatively simple arguments. What we do is we capture with an expression, the expression, right? Then we use new function to define a function with argument x, and then just put the expression in there. Because remember, new function takes an expression. So we don't want to splice it. We don't want to do anything else. We want to give it the expression as expression object. And the rest of it's all straightforward, just plotting a function. Now we've got the function. So it's a cool example. But by the way, things like this, like, oh, do I have to splice this in or not? That's the kind of stuff I get tripped up on every time I'm reading this stuff. Like, wait a minute, why are we not splicing it there? Why we didn't splice that? Sometimes I find that a little confusing. It requires some reflection, I guess you might say. So I said, oh, you obviously don't splice it. It wasn't obvious to me when the first time I read this. Like, wait, why don't you splice it in? But now I realize new function wants an expression, so I shouldn't do anything to it. Just give it to it as is. So,
because if we spliced it, it would basically be like we're not putting. So once we splice it, it's no longer a expression; it's a component of an expression, right? Am I saying that right?
I'm not sure.
Or
I mean, it gives an error. When I just tried it for the heck of it in like R prompt, and I go, put the splice thing in there, or the inject. I mean, inject operator for expression. It just says error in type expression, invalid argument type. So I don't know.
Oh, but well, no, because
what does it mean?
Well, because like if you tried to do like the bang bang or slice, it's unquoting, right? It's doing the unquoting, so it's no longer
Right.
quoted. So
It's not evaluating. It's taking the. I don't know.
It's would it be?
You're right.
It's the idea of quoting and unquoting, right?
Yeah,
so like if
you're
you
right.
tried to
It is
splice it here, then it would unquote it, so it's no
Right.
longer an expression.
So, yeah, you're
And so
right.
that and new function is expecting that function. This new function is expecting an expression as its input.
Yeah.
Huh. At least that's the way I understand it from the way that you kind of explained it.
Yeah, I think that's right. I just tried it and it does give an error. There's some cases where it doesn't actually matter whether you splice or don't splice. Like in that other previous example, where was it? Way back here. This one, it doesn't really matter whether you splice or don't splice arg value. It has the same effect. Because it's just a constant, I guess, right? That's probably why. Oh, I forgot to mention this thing. How come I didn't mention that? Did I forget to even talk about it?
I think we talked about it last week.
Oh, okay, we did. Yeah, we did. Yeah, we did. There it is. This is the same as the, this looks the same. This is what you were talking about, the walrus operator. It's not the wall. I don't think it's called the walrus operator in this context, but it looks like a walrus. So this is totally different use of this operator, I guess.
I think that comes from like Python. I think
Okay.
Robert was saying it last week.
Okay.
Called it the
Oh,
walrus,
yeah,
but-
it's a Python thing, right? Okay.
Yeah, and so I'm like mixing up the language for different things. And
Me
R, it's
too.
not. It doesn't have a special name to it. That's
Okay.
interesting.
Well, anyway, that wraps up that. In this chapter, we talked about some of the non-standard evaluation with quasi-quotation, and our brain continues to get turned to mush by this stuff. At least mine does. And the next chapter, we're going to look at, or that's what Ryan's going to take over right now, and talk about how to unleash the full power of tidy evaluation with the closures and data maps, with the other two legs of the of a tidy evaluation. And with that, I will stop sharing. Any other comments or questions that I can't answer? Probably will get wrong about quasi-quotation.
All right.
Basically, what my advice is, just splice everything, and if it doesn't work, try unsplicing. I'm just kidding. I kid. We all do that, though. Don't we? That didn't work.
Yeah.
Let me try a couple of bags. Okay, that'll work.
Yeah, I'm still like, there definitely are aspects of all that stuff that I'm still like trying to remember, like, oh, what does at least the symbol mean? There's like just basic sort of memorization that I'm still coming up on. All right, so I think this is like the last chapter in this sequence, right? I mean, I think next week we're doing something like about R code or something. It's not like this is like the last big.
Yeah, well, I think the next chapter is the kind of like an example of using all this.
Oh, right.
Is that what it is? Yeah.
Yeah. I think it's using these like metaprogramming concepts to translate it into like HTML and SQL and different languges.
Yeah. Well, anyway,
and then we're done with this section. Then we
seems like this seems like a kind of a, I mean, the last of a series of things related to metaprogramming. So yeah, we're going to talk about evaluation, which, you know, the big ideas are obviously the concept of evaluation, what that means and how we do it. We'll talk about this idea of closures, which, as I mentioned at the top of the hour, this was something that I spent a lot of time cursing when I would have errors and there would be some weird reference to a closure or something that I didn't understand. And so, of course, I didn't spend that much time figuring out what it was until now, but there you go. And then lastly, we'll talk about this idea of a data mask, which I kind of understand, but like some things in this chapter, like they just kind of touch on something and then they let it go, and it's not totally clear to me all that we're doing. But we'll have a chat about it. I'm sure we'll have chances to work on it later. So yeah, so real basic thing, like you know, they authors talk about this idea of, you know, the additive, you know, kind of sum of having quasi-quotation plus closures plus data masks is what tidy evaluation or non-standard evaluation is in the case of R. And so yeah, I mean, obviously we just talked about quasi-quotation, and I'll talk about the latter two. And so basically authors talk about tidy eval as being a principled approach to an SE that makes it possible to use functions both interactively and embedded within other factors. I'm not really sure what makes it principled per se, I guess, other than just like, well, I mean, they tried to make it as kind of clean and clear as possible. I'm not sure. So yeah, let's talk about what an evaluation is. So eval as a function evaluates an input expression in an input environment. So those are two important things where, you know, I think until recently we were mostly just focused on this idea of expression, but now we are also thinking about this idea of, not only where are we what are we evaluating, but where are we evaluating it in, which has implications for which, values we might take. So yeah, nothing really special here, just we set a value and just evaluate it. And and obviously in this case, the environment is, the global environment that we're using currently. So, but it gets a little bit trickier as we, things can become different if we start changing the environment. So like this example here, this is all global environment stuff where we have X was already defined in the global environment up above. So now we get 12, but we can also do the exact same thing and add this new piece of an environment where X is equal to 1,000. So we're still, what's kind of remarkable, I guess, is, and this is my first thought when I saw this was, so why isn't there an error? Because we haven't defined Y in the new environment. But I guess that's where the whole lexical scoping comes in, right? If there's no Y in this newfangled environment that we created, then we just go looking, up a level or whatever, down a level, however you want to say it. So
yeah. What's not shown there when you create an environment is it automatically also tacks on the parent environment, which in this case would be the global, right?
Right. So yeah, when we don't set this as an expression, it will just do this as it won't utilize this new environment, right? So one of the things I guess I didn't really understand about this is like in the book, I guess why put print, because when you just do this, it does the same thing. I guess it's just more about being explicit, I guess, using the word the print function, I guess, whatever. Anyway, so
well, I think well, because of that, like, isn't the plus is a function? So if you do x plus 1, every function has a print method, right? So it would just print it regardless, even if you are
right,
like just calling print explicitly.
Yeah, that's all.
That's
That's all. I mean, it's ticky-tacky stuff. I'm probably just being silly, but yeah. So the only difference here between this and this is this: we're now explicitly calling this an expression, which then gets evaluated. And because we're doing evaluation in this new environment where X is equal to 1,000, we get a very different answer. So yeah, I mean, I think we've kind of touched on this a little bit already with some of the stuff in terms of environments and, expressions and stuff. But one of the things, they talk about is this idea of local, which I'll be honest, like I've seen this a lot, but this is another one of those things where I've seen this function in like code and stuff, and I never really kind of asked, what's up. So it's a base R function that allows you to carry out a bunch of steps in a new environment and like chuck the intermediate sort of results, which is good because depending on how much data you have, the intermediate steps can take a lot of space up. So an example of this would be here we're saying let's define X, let's define Y, and then let's add them together, and of course we get 210. But if we were to go and ask where X and Y are, we would get there's no such thing, right? One of the things they do a lot in this chapter, which I guess maybe I'll just say what I think he's doing, but I'm not even really sure, is it seems like they just kind of like want to remake like kind of well-known base R things just to show like how easy it is, I guess, or relatively easy. It's just really about kind of setting the expression, setting the environment, setting all the blah 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 blah, all this stuff. And so this, I guess, this local 2 that we're creating here is just a different way of doing that same thing. Remember, we use nx or whatever instead of expression because we're doing it inside of a function. If you remember that, that was something that came up, I think, in the intro to metaprogramming chapter. So yeah, so if we so now this function says, give me an expression, and we're going to create a new, by the way, maybe you guys said this in the last chapter. So when we say caller environment, are we just saying that that's like the global environment unless we specify something else? Is that what we're saying here? Or is it caller environment just like some new environment that we haven't really defined? There's no values. We're just saying this is a different environment from the global environment.
I got confused by that too, because I had to remember what caller environment does.
I think it's the caller environment is the environment of the caller, which could be the global environment, most like you're just calling that from the command line or from the top level, but it could also be inside some other function, right? Whether you're calling that, and then it will include that function environment, right? So if anything, if you're inside of another function, you call this function, then it'll capture those. It'll point to that as a parent environment. So like if you had X defined in your function, it'll know what X is, right?
Right. I guess maybe this is another way to say it. So okay, so let's say instead of having the second line where it says eval and express all that stuff, we had a bunch of other stuff where like we defined what X and Y are and did a bunch of stuff with it. So I guess my question is so X and Y would be in the values of X and Y would be in this caller environment, which would not be the global environment, right? Is that fair to say? Because we would say, do all this stuff in this env that we just defined. Is that fair to say?
Not if you did it inside this function. I mean, if you're inside another function we call local2, right? The caller, it's when you call local2 is when the caller environment is defined. If you define things inside this,
that's what I mean. Sorry, when you call it,
yeah. If you define things inside this definition of local2, then it's not going to be captured. Right?
Okay. So anyway, if so for this we get this, but I think I took this out now that I think about it, but maybe I'm wrong. But like, so if we ask, like what's X? Well, actually we would have a definition, but I think it's from something else actually, now that I think about it. We don't have 10. So yeah, I defined X from a previous thing, but yeah, all right. So at first I was like, what do you mean gotcha? Is this like a function that we're trying to like learn about? No, I think what they're trying to say here is in this part of the chapter is sometimes things that we don't think will work because of sort of vagaries of how base function stuff works. So we define all this stuff and then we evaluate, and we don't do n-express, we do expression, and then we say, okay, here's a function, it's just an anonymous function with X and Y, and then we're going to do our bang bangs for both and call this. So they say in the book this function doesn't look like it will work, but it does. This is because if available functions print their srcref, which I guess is short term for source reference, right? So this is going all the way back to 621. Like all objects in R, functions can also possess any number of additional attributes. One attribute used is this short reference. It points to the source code used to create the function. It's used for printing because like body, it contains code comments. And so to work around this, we can either use new function, which you just talked about, or remove the attribute, right? So right now, if I were just to call the function, this is what it would look like, right? But if I were to first say, hey, go into this function for this attribute, make it null, and then call the function again, it's, oh, wait a minute, what happened? Why did it do? It doesn't seem right. Wait a minute.
Yeah, it didn't seem right. Did they fix something about that?
No, I don't think so.
Okay, there you go. That's what's, yeah, you must have already.
Oh, right. Sorry, I must, yeah, sorry. So, yeah, so this is all.
This is what he means by this, right? That thing you just highlighted is what he means. This doesn't look like it will work because it's like, wait a minute, that looks.
Yeah,
wrong.
so this is the SR, this is the source reference or whatever, and then this part, yeah, okay. So everyone sees that. So this is the actual expression, or whatever, but okay. All right, here's this is one of the questions in the book. We have 3 different lines. There's 1, 2, 3. What do you think is the output going to be for the first one? Obviously, we would never want to code this way. This is just for funsies, but I think well, hopefully it's evident that like what we're trying to do is figure out how many evals and how many expressions do we have, and if we have more than one or the other, what is that? What's the implication?
I mean, I already know the answer because
Oh, you already looked it up?
I know I worked through it, but
Okay.
Initially I was confused by this because at first you're like, oh, I mean,
Like, why would you even do this, right? I mean, I think it's kind of a silly example, but I think it's one where, if you have, more of one than the other. So what's the first one? What would it evaluate to?
well, it evaluates the 4 because every eval cancels out every
Right.
expression.
Because there's 3 full pairs of each, right? So you have evals.
And the outer one's an eval. Like that's important too.
Yeah. Oh, right. Yeah, good point. And then so this is a little bit trickier because we have 2 evals, and then so what do you think's happening here?
So the 2 evals don't matter. I mean, they're still gonna,
Right.
The outer eval is gonna basically just go right to the inner eval, which is gonna just keep doing what you did above. So it's gonna be 4
Yeah.
again.
Than before again, right? Because good catch on there's an extra eval. And then this last one where we have eval express, and then we have an expression for this whole thing. So when we take this whole thing and we say, let's make it an expression, what's that going to give us? I think I'm kind of giving it away, but it's this holy terror, right? Probably not something we would choose to want to do. Anyway, there you go.
It is a little bit confusing though, right? Because
yeah,
I mean, in one way it's like, oh, it's very straightforward. Every eval cancels out an expression. The other way you think, well, if I'm evaluating an expression call, shouldn't that do what an expression call does and just return the expression and capture it? I mean, doesn't it get evaluated when I type it at the command line? I don't know why. There's some funkiness going on there, right? It's some in my mind. There's some funkiness going on. It's like,
I just thought it would be like an easy thing for us to try to work through and together. So I'm not gonna lie, like that was a big, huge part of my decision process. But all right. So now closures is like I feel like this is for me, so much of this has been leading to this, right? Like, so what, like why do we need these and what are they?
Right.
Well, so the problem and scope. Okay, so here's the deal. Almost every use of eval involves an expression and environment, even if the environment is implicit. I mean, like we don't have this, it's sort of, we're still kind of defining it by not defining it. This coupling is so important. We need a data structure that holds them both in place. Base R doesn't have this, so Arlang created closures, which we would call a composite structure that is the encapsulation of both. And so quoting and closures is sort of like how we get that word. It's like that's sort of the combination of that, because a closure both quotes the expression and encloses the environment, right? So basically the whole gist of this is, and I'll be honest, like I'm still trying to reckon with this, but the thing I think helped for me most later on in the chapter, they say really the advantage of having closures is it allows you to pass around one thing instead of 2, which I think is a pretty damn good reason to do it, right? It's like, I mean, we're talking about efficiency and sort of like, optimization or whatever. It's like, just create this thing that you can then do stuff with, right? So there's 3 kinds of closures, and like a lot of things that we've talked about so far I almost said semester. God, this is, I feel like they teach us one good way and like 2 needless ways that I'm not really sure why they're teaching us, other than just to show that there's more than one way to do it. So this whole enclose thing is, they call it this the best way, which is, okay, let's create a function whose only job is to create this this expression, and since we're not defining the environment, I guess it's just the global environment. So yeah, if we were to make this closure create function, we get 2 things. We get an expression and we get an environment, right? So actually, I don't know, maybe like just as a for funsies, I don't know, like if I were just to do this, I don't know, can I do this? I don't know. Actually, wait a minute, can I tag that on at the end of the, I don't know if I can or not, it's in the end quotes, but yeah, I don't know. Maybe I think we can define the environment layer. Maybe I should think about this more, but all right, well, anyway.
What do the little hats mean? Like, or the caret A, you know,
I think that little caret is just to show that it is indeed an expression, I guess. It's like, I don't, since they can't quote, I think maybe like literally like put quote marks around stuff. Maybe that's what it means. That's a good question though. I don't, you have any ideas? That's a, yeah. It's a
No.
worthy question. I just don't have an answer. And then yeah, we can also do lists, right? So we can and then we have to use end quotes instead of end quote. And so yeah, so same thing where, you know, the whole expression put into the function underneath is what we get back. Okay, so then they talk about the second way, which is to use quo and quos. And so basically, I guess they're saying these exist to match express and expressions, which I'm kind of like, don't end quo and quos do the same thing already? I don't know why this is important, but whatever. But they are only included for the sake of completeness and are needed very rarely. If you find yourself using them, think carefully if expression and careful on quoting can eliminate the need to capture the environment. So whatever, I'm gonna just leave that there. And then last one is this idea of new closure creates a closure from its component expression environment. This is rarely needed in practice, but useful for learning. So it's used a lot in this chapter. So, you know, same thing. Notice how it looks a little different, like the coloring, I guess. So I don't know why that is, but for that blue tint. So, by the way, I did use, this is the first cohort, I guess. You know, I used a lot of his stuff as a guide, and yeah, so this is an interesting thing. It's just to kind of show like what's happening with closures under the hood, right? So we create a closure, you know, like what is it? Okay, so first thing, it's a closure, but it's also a formula, right? Because we're including stuff in the expression. Is it a call? You know, the call objects are something we've obviously been dealing with or thinking about. And then this idea of, you know, what's the environment? You know, it's in the global environment because we didn't specify anything about the environment. And oh yeah, so you know, just get the expression and get environment. So this is all just the same kind of stuff, right? So whether you do get env or do all this, you're going to get to the environment. So yeah, so I mean, basically, one of the things they say is you know, just using tidy underscore eval is basically just a shortcut for doing eval, you know, get expression, and then you know, get environment. And so basically, it's like, yeah, that kind of helped me actually a little bit in terms of thinking about, you know, like why, you know, we're doing this. I mean, I'm still challenged, but yeah, I think this is starting to make more sense. So however, there are two unique important features: this idea of nested closures and pronouns, which I will get back to. Pronouns really are just about this thing that Ron was talking about, which is how we specify, you know, which environment is, you know, are we messing with. You did something with that, I thought. So closures are paired with a new evaluation mode that takes a straight single closure instead of a expression environment pair. Once again, you know, this whole idea of passing around one thing versus two. So we create this new closure with an expression of x plus y, and then we create an environment, which is what I was going to do up above with end quo, but I chickened out. So yeah, so we specified the values for one and excuse me, for x and y, and so we're just evaluating the whole thing in tidy eval. So I'm going really fast. Any questions or anything so far? So
well,
yeah,
I was thinking, I was looking in the R-line documentation and you know, and was looking at the embrace operator, and it's really interesting to see how the embrace operator relates to onquo. Like if you look at the, like under the hood, like here I can pass this along in the chat, but it kind of shows like how the embrace operator simplifies the use of the unquote inside of a function. And so I thought that was kind of neat. Pass it here.
But that must have been introduced after this book was written then, eh?
Yeah, it was, but I think it gets rid of that fact of needing to like have both the expression and the environment packaged together. Because at the end of the day, like when you do like the double embrace, you're just looking for like what's defined in the global environment. So, I mean, that's the environment that you're going to be referring to most of the time. I think if I'm like looking at some of the examples, but let me pass this along.
Okay.
But it really shows like the equivalence between the two. Like they do this function where it's like my mean, and then it shows like the equivalence of like using the embrace operator is equivalent to where you just unquote the variable. So I just stumbled across that while you were kind of going through.
Yeah, that's good stuff. Yeah, there's a whole like I think we talked about it a week or two ago, but yeah, there is an Erlang like group on the site now, and they have YouTube clips that I have been slowly like setting aside to watch, but I haven't watched them yet. So have you been watching those at all? The Erlang group?
A little bit. I wanted to participate in them, but I had another weekly meeting around that time, so I couldn't do it.
Yeah, hard to get it all in, man.
Indeed.
The way life is. Okay, so yeah, this one I kind of the last two or three concepts which we're going to talk about nested closures, we're going to talk about pronouns, we're going to talk about data masks. I kind of get it, I kind of don't. I don't know. Anything you guys could kick in, I would be grateful. So it's possible to use Quasiquotation to embed a closure in an expression, so we can create two closures here. Or we're using that new closure thing, which I guess we could just use enquo instead, I guess. Actually, let me try that at least. Or would this throw an error? I don't know. Oh, yeah. So so I guess enquo doesn't like the environment thing.
Yeah, because enquo captures whatever environment it's in automatically, right? That's
Well, anyway, okay, so we're going to use new underscore closure, and then yeah, so we're defining the environment, and so that means X is going to be worth different values, and so I guess that's the nesting, right? Is the nesting is X means different things depending on which closure you're in, right? Okay, so yeah, so all right. So any questions about that? I don't know necessarily why nested closures are useful or not. I mean, I guess I don't know. I can't. This is one I had a hard time thinking of like a pragmatic usage or utility of it. But if you guys have any ideas.
Okay, so I do have a couple questions about this.
Yeah.
Okay, so well, I'm just like maybe talk through it here. So we're creating a closure here, which
Right.
the closure is just a data structure that combines an expression with an environment.
Right.
Then when we do this expression part right here, what we're doing is with the splice, we're just expanding that closure into that Q2 and then that closure into Q3.
Right.
But I guess where it kind of gets muddy for me is the environment objects, right? Like once it splices it in it, is it just using the closure?
Uh-huh.
So I guess I'm just getting confused where like the environment.
what is.
Like,
Can you type out what X is right now? Just like type X on the.
Oh, sure, yeah. Yeah, no, that's a good one.
That's no help at all.
yeah,
Sorry, Ron. Well, I
that's
guess
what got confusing.
Yeah.
Go ahead.
So I guess let me try to like be
What
like,
is X?
let me try to be the R guy who's going to explain to you why this is a great idea. So yeah, like what are we doing with the environment? I guess once again, it's like the advantage of doing it this way is we've just passed it Q2 and Q3 as one object, right? And we've got two pieces of information that gets evaluated together. But Yeah, so I mean, I guess if for whatever reason you need X to mean different things in different expressions or whatever, it's interesting.
Okay, but this goes back to it. When we splice it, splicing evaluates it, right?
Right.
Is that true? Because expanding means that it's going to evaluate it as well. So it's going to evaluate whatever that expression is. So that expression, so Q2 would automatically evaluate into 1, right?
That's what I was expecting
And
to see, but instead we got twiddle X and.
I know,
Oh,
that's what's throwing me off.
No, because we haven't evaluated. So no, hold on. This is sorry. So this is now we have created all the expression and closure marriages and X here. And so for us to actually use, we have to do tidy eval. But
Because I thought the splicing evaluated, unless it's not a function, right? I thought it. Maybe I'm getting my terminology mixed up here and how this is supposed to behave. But I thought like when you spliced it, if it was a function, it would evaluate it. If you spliced it,
it does get evaluated, I think. Oh no, wait a minute. Hold on. I see what your point is. Well, hold on. I see your point, because what we're doing here is we're making one big sort of compound expression by including these two. I see so so far we've never said anything about, okay, right. So no, what you're saying here is, okay, so think about the splicing or the bang bang. I think of it as bang bang operator, sorry. So like we have, so basically what we're doing is we're saying, hey, let's make an expression called bang bang Q2 plus bang bang Q3. So it's true. I mean, we haven't evaluated anything after we've defined X. And so it makes sense to me, kind of, but I'm not sure how much that's really worth it. Because you'll understand this a lot more than I do.
Yeah,
But
so it says X is I looked at X and like it's a call. That's the class, the language thing. It doesn't.
But the call is not to evaluate; it's to make an expression called bang bang Q2, right? Plus bang bang Q3. So the whole first chunk is about creating this kind of complicated, convoluted expression, right? That we then just evaluate with X. Now, maybe is it confusing because I defined the whole thing as X at the bottom? Is that why? Because X is like 3 different things depending on which environment we're in, right? So in Q2, it's equal to 1, it's equal to 10 in Q3, and then in the global environment, it's equal to, the whole expression, right? Yeah. Let me just do this because actually, you know what? We're out of time, and I still have quite a bit left to do. Why don't we just let's bring this back, and I'll see if I can get anything else good about it. We don't have to just leave it alone.
Yeah, I don't understand what
I share. I share Colin's frustration, except I have so many frustrations with so many other things. I don't know.
I would just like to know where the 1 and the 10 are hidden inside that X object before you eval tidy it. Like, where is it? Like, is there an environment pointer in there somewhere? I've like tried everything I do, like structure,
right.
It has no attributes. What is that thing? It's really a mystery.
Well, okay. Well, what is Q2? Like, okay, Q2 is a quosure.
That's a quosure,
right?
Sure. Yeah.
What if you just did bang bang Q2 in the console? What would happen? I don't want to take up any more of your time.
Just do this.
I mean, I can test this on my own too.
So it should be
it?
1, right?
No.
Oh.
Yeah, you can't do that. Not allowed.
Ron, I'm talking about communication. This is your biz. This is your jam here. Okay. That's actually, I'm actually glad you persisted with this, Colin. This is I would not have.
But you can eval tidy Q1 and you'll get 1, and you eval tidy Q2 and you get 10.
Tidy eval, you're saying?
Yeah. Eval tidy. Yeah. It's eval tidy. I get it backwards all the time too.
Oh, is it?
I'm not sure why they did, but
oh goodness.
Hadley likes to do the verb eval.
So I don't know, but the weird thing is that before you eval tidy eval X, it's like it's like in a weird state.
Yeah, I mean, maybe to your point, Colin, can we put like instead of bang bang, can we put eval as a function before Q2 and Q3? Would that do something? Would that still would that even evaluate? I know because it's you couldn't because you couldn't have that. You couldn't have that in the expression, right? I don't know.
I just need a diagram, I think if I could see it visually, like, you know, with like the environments, because you technically have two separate environments, right?
Three,
Like
three.
you have three, yeah. Well, you have the global, yeah, you have the global, and then you have like that environment X equals 1, and then environment that has this X equals 10. So there's 3 different environments.
Right.
I just don't know where the environments come into play when you splice it into this expression.
Me either.
And,
I mean,
They got to be hidden somewhere.
And get that Tweedle,
yeah.
And getting that Tweedle X and that whatever when it comes back, it's just like.
I think it has something to do with the base formula, the way base formulas work, because that is the same kind of twiddle. And I do remember vaguely him saying something about that formulas are kind of like a base R closure in some weird way, but in a very limited way.
Well, let's address this next week. Maybe we'll have some more time with it, but so I will oh, by the way, also there was like one chapter that was without a presenter, and I took that one. That was like in like 3 or 4 weeks or something. So I think we're all set for presenters, I think, through the duration.
Oh, okay.
I think
I think we're good to go with that. I think because we got evaluation and translating R code. I'll reach out to Robert to see if he can still cover that one. Next week, because I think how long do you think we'll need to finish?
Oh, it'd be like kind of, well, it'll be shorter than what Ron had. I mean, probably 15-20 minutes at most, I think. Depends on how engaged we get, right? I mean, that's really the limit. It's not me, it's us, I think. Which, you know, is totally cool. I don't know that we're in such a rush, but yeah, I think, you know, no more than 20 minutes probably.
I think the thing comes down to understanding what the heck these call objects actually are, you know.
Yeah,
that's what I struggle with, is like trying to figure out what they are. Like, what are they? Like, you're putting 2 data structures together to create this combination of a data structure. So it's like, because an environment's a data structure, and an expression is a data structure.
right.
But then you're trying to create an expression of it. Well, that's why they're nested, right? You're nesting that within it, so that's why it's a nested. Okay.
Because otherwise, if you wanted to do that expression where you needed X to mean different things in different places, like that would be the whole, like, now you have to figure out some way to pass 2 things that are together, right? And so yeah, I don't claim to have any great understanding other than that's, you know, that resonated with me. This, you know, don't pass 2 things, pass one. That kind of seemed to make sense. But
yeah.
Well, cool.
Yeah,
well, I think we finish up this next week, and then I'll reach out to Robert and see if he's still going to cover translating our code, and then we'll go from there. So all right, we'll talk to you guys later.
All right, see you next week.
take care.
Thanks, y'all. Have a good one.
Yeah, you
Bye.
too.